This lesson really builds off nested triangles and side splitters. It's a special situation called midsegments. So building off yesterday, what do you notice here? What are you wondering about? Well, I noticed that AN and CN are equal, so N has got to be the midpoint of CA. So maybe if this was 5 inches, this would be 5 inches, right? And then same thing down here. A to M is the same size as B to M. Maybe it's 6 and 6, but M is the midpoint of that side. I also notice these lines are parallel. So that little arrow means they're parallel. All right. So how do you know when you're halfway, exactly halfway? Well, we want to be right in the middle. So I want these two numbers to be equal, 4.24, 4.24, 3.61, 3.61. And then notice the parallel signs, 5 and 10, right? Twice as big there. So that's how we know we're exactly halfway on the triangle. That's the midpoints, midpoint, and this parallel side is twice as big as the other parallel side, or half, depending on which way you're going. So this thing is called a midsegment. When it's right there in the middle of one side and the middle of another, if we connect them, it's called a midsegment. And it's exactly half the length of the side parallel to it. So if this side AC was 12, the midsegment would be 6. So it's just a special property that happens when we have those nested triangles. So in this one, DE is a midsegment, right? It says it right there. That means D to B is the same as D to A. E to B is the same as E to C. So if DE is 7, AD is 5, BC is 13. So BC is the whole side. So careful there, 13. Find the perimeter of triangle ABC. So I got to find all three sides. Well, right away, I know this side is 5. So this side has got to be 5, right? Because that's the midpoint of that side. E's the midpoint of the right side. All right, so I got this whole side is 10. This whole side is 13. What is the bottom going to be? Well, I know DE is 7. So if it's the midsegment, this has got to be twice as big. This has got to be 14. So the perimeter of triangle ABC is 10 plus 13 plus 14, which ends up being 37. So 37 is the perimeter. Now, what I could have done, I could have separated the two triangles. We had 5, we had 7, and then the whole side was 10, right? This was 5 and 5, so 10, and we didn't know this side. So we could have set up a proportion. 5 out of 10, right? Match up those matching sides. 5 divided by 10 equals 7 divided by x. Now, you could see it like, oh, it's just twice as big over there, but let's multiply it out and just see. So 5x equals 70. Let's do 70 divided by 5. This is just another way to do it. Oh, we get 14 still. So that missing side was still 14 down here. So proportion works, but usually it's pretty easy since a midsegment, you could just see, oh, it's just twice as big because it's exactly half. This triangle is exactly half the size of the bigger triangle. So usually those are pretty easy. You don't have to do the proportion. You can see them in your head, but just in case. All right, we had some partner practice. And then there's a few that were like a little challenging where like there's multiple midsegments. And one thing to just notice, this would be 6, right? That's in the middle. This would be 4.16. So this side, if this whole side is 8 point whatever those added together is, this is exactly half of it. So it's got to be 4.16. So those parallel lines end up being equal. 4.16, it's half of this side. So half of it's 4.16. So it's just the same right there. You could also see, right, that's a parallelogram. And the opposite sides of the parallelogram are equal. Another way to think about it. Or there's a parallelogram here. So this side has got to be equal to this side. And then that works for all the parallelograms. So let me go back, like this one.